Hi students, now I am going to explain properties of carboxylic acid. Properties of properties of carboxylic acid. Carboxylic acids. Okay, very important, my dear students. Carboxylic acids with the number of carbons that is 1 to 9, they are it is a liquids. It is very important. Carboxylic acid with 1 to 9 carbons, that means it is a methanoic acid, ethanoic acid up to 9 carbons. It is a liquids. Next one, greater than 9 carbons. Greater than 9 carbons means it is from 10 carbons, 11 carbons, 12 carbons. They are, it is a solids. That is, it is especially for it is a wax solids. It is very important, my dear students. They are liquids. They are, it is a unpleasant smell. Okay, there is, it is a no smell. It is very important, my dear students. Carboxylic acids are soluble in water due to the presence of, it is a hydrogen bonding. Is very important. Next one, suppose if you take acetic acid can existing as a dimer form. Suppose, see here, it is a CH3 C double bond O and O, it is H. See here, O, it is a H. Similarly, it is another acetic acid molecule, CH3, it is a C, it is a OH. Next one, it is a double bond, it is O. See all of you. So it is a carbon, oxygen and hydrogen. Likewise, partially positive charge. It is a partially negative charge because of oxygen is more electronegative than hydrogen. Similarly, it is a partially negative, it is a partially positive. This is the hydrogen bonding. Very important. Next one. So same. Similarly, it is a partially negative charge. It is a partially positive. It is a partially positive. It is a partially negative. This is the hydrogen bonding. So that is a acetic acid can existing as the dimer. Okay, next one. It is very important. The boiling point of liquids, the boiling point of carboxylic acids are higher than that of alcohols. Okay, comparable molecular masses. Very important, my dear students. Okay, so this is a one more important point. That is a, you have to see there, is a very important. Next one, acidic nature of. It is a acidic nature of carboxylic acid. We have to explain this one. Acidic nature of carboxylic acid. Acidic nature. See here. This is very important concept. Carboxylic acids. Acidic nature. Acidic nature. Very important, my dear students. See here. It is a CH3 COOH in presence of water. What happened here? It is a this one. So it is ready to do, release H plus ions. It is attacking here only. You will get H3O plus. H3O plus it is a CH3COO minus. It is a carboxylate ion. So according to equilibrium, it is a K equilibrium is equal to K equilibrium is equal to products by reactants. That is H3O plus concentration CH3COO minus concentration divided by, it is a H2O concentration and the CH3COOH its concentration. Very important, my dear students. Next one, it is a K equilibrium. It is a K for constant. K equilibrium H2O. It is equal to, see here, it is a H3O plus CH3COO minus divided by, it is a CH3COOH. Okay, so this is equal to, it is a Ka. What for Ka? Ka is equal to dissociation constant. Dissociation constant for acids. It is very important, my dear students. Dissociation constant for acids. Okay. See here, it is a Ka is equal to dissociation constant. What is the useful for this reaction? It is a Ka is directly proportional to this one. So it is a Ka is directly proportional to acidic strength. It is very important. Acidic strength. Ka is directly proportional to acidic strength. Ka is very important. Ka is directly proportional to H plus ions. Very important, my dear students. Ka is inversely proportional to pKa. It is very, very important, my dear students. What is the relation between it is a pKa and Ka? pKa is equal to minus log of it is Ka. These are the formulas. My dear students, Ka dissociation constant value increase, acidic strength increase. H plus ion concentration increase, acidic strength increase, because of both are directly proportional to. Next one, Ka is inversely proportional to, it is a pKa. pKa is equal to minus log of it is a Ka. It is very important, my dear students. We have to remember this. Okay, next one. Okay, I hope it is this is very important, my dear students. Next one, I'll give one clarity. Suppose, example, I am saying it is example. Example, it is a pKa, sorry, Ka is inversely proportional to it is a pKa. What is the meaning here, my dear students? pKa value increases, acidic strength decreases. Okay, suppose in case it is a B, C, D, different types of acids. It is a Ka values. That is a 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 4, 10 to the power minus 5. See here, which is the strong acid here? It is a Ka is directly proportional to strength of acids. Sa means strength of acids. Which is higher value here? A is higher value. That's why it is A is greater than, B is greater than, C is greater than, it is D. Similarly, if you take the same thing, if you take it is a same thing, you have to see there. Okay, suppose it is a pKa values, different acids, A, B, C, D. Okay, so different acids. Which is strong acid here? pKa value increases, acidic strength decreases. Which is strong acid here? D is the strong acid. In terms of it is a pKa value, that is D is greater than, C is greater than, B is greater than A. I hope all the students are understood this one. I will give it is a one best example. See all of you. HCl. Okay, see here it is a HCl. Next one, phenol. It is a phenol. HCl phenol. It is equal to minus 7. It is equal to 10. It is 10. It is a C2H5OH. It is a C2H5OH. It is 16. It is a 16. It is a CH3COOH. It is a 4.26. 4.76. Sorry, 4.76. It is a CF3. It is a COOH. It is equal to, what is that value? 0.23. These all are, it is a pKa values. These all are, it is a not Ka values. These all are, it is a pKa values. Very, very important, my dear students. These are pKa values. Okay, so what is the meaning here, my dear students? Ka is inversely proportional to, it is a pKa. I told clearly, Ka value increases, acidic strength increase. Ka value decreases, okay, Ka value decrease, pKa value decreases, acidic strength increases. You have to verify here which is the least pK value. It is HCl. Okay, so okay, order of this one, it is 1, it is 2, it is 3, it is 4, it is 5. These all are pKa values. Order of acidic strength. Which one is least value here? 1. 1 is greater than. Next one, my dear students, CF3COOH. It is a 5 is greater than. Next one, it is a 4. It is a 4 is greater than. Next one, 2 and 3. Which is the least value here, my dear students? 2. Phenol. It is a 2. And the next one, it is a acetic acid, sorry, ethyl alcohol. It is a 3. You have to comparison here only. Suppose comparison between acetic acid. It is a carboxylic acid and it is a mineral acids. Mineral acids are always stronger than it is a carboxylic acid compared to here only. Okay, so mineral, this is the generalized statement. Carboxylic acids are weak acids than mineral acids. So mineral acids are HCl, H2SO4, HNO3. So according to this one, this is the strong. Okay, that is the one statement. Next one, comparison between acetic acid and this one. Acetic acid, it is acetic acid is ethyl alcohol, which is more acidic in nature. It is a CH3COOH is a least pKa value. That's why CH3COOH is a strong acid than ethyl alcohol. What is the reason? See here, suppose, see here my dear students, CH3, C double bond O, it is a O, it is a H, gives rise to, my dear students, very important my dear students, see here. So it loses, okay, it is lone pair, lone pair, lone pair. Each oxygen contains 2 lone pairs. So these 2 electrons are gained by this oxygen, it releases a H plus ions. What the remaining, my dear students? It is a CH3, C double bond O, lone pair and lone pair. Next one O, lone pair, lone pair, lone pair. It is a mites. It is a mites. Okay, so it is a carboxylate ion. I will write down only it is a carboxylate ion. It has. Suppose these 2 electrons are shifting here only. It is going back. You will get a CH3, C. It is O, lone pair, it is a lone pair, it is a minus, double bond, lone pair and lone pair. These 2 are resonance structures. Okay, so suppose if you take this a CH3, CH2, okay, it is a OH, these rise to. It is a lone pair. These 2 electrons are gained by this one. You get this one only. That is a CH3. CH2, it is a O minus, that means it is a lone pair. Okay, minus it is a H plus. They don't have resonance structures for ethoxide ion, but a carboxylate ion it contains, it is a lone pair. That's why this is a carboxylic acid. Okay, carboxylic acid, it is a more acidic in nature than alcohol due to carboxylate ion. Due to resonance of it is a carboxylate ion. It is very important my dear students. So these 2 are completed. This is also completed because of it is a HCl. It is a mineral acid. It is a carboxylic acid. Mineral acids are always stronger than this one. Next one, phenol. Okay, phenol also can exhibit it is a resonance structures. But it is this is the more stable. That's why it is a carboxylic acid. Carboxylic acid is more phenol and alcohol. It is a aliphatic alcohol. It is a aromatic alcohol. It is what is the conclusion, my dear students? The acidic nature of carboxylic acid is greater than that of alcohol. Either aromatic alcohol or it is a aliphatic alcohol. Next one, see here. Comparison between, okay, so this and this one, it is a acetic acid, it is a trifluoroacetic acid. Trifluoroacetic acid has more acidic nature than acetic acid. Why? What is the reason? My dear students, listen carefully. Suppose, this is very important my dear students. Okay, see here, very important. C double bond O, lone pair, it is lone pair. It is O, lone pair, lone pair, lone pair, it is minus. G is raised to, it is a G. G for group, listen here. Okay, so it contains electron with drying group. It is a with drying group. It is a with drying group. It is very important, my dear students. It stabilizes the carboxylate ion. Okay, if carboxylate ion contains, it is a electron with drying groups, it stabilizes the carboxylate ion. Ultimately, acidic strength increases. Acidic strength. Okay, it is a acidic strength increases. Very important, my dear students. If carboxylate ion contains, it is an electron with drying groups. Ultimately, stability increases, acidic strength increases. Okay, suppose it is a F3. So fluorine is fluorine. It is a electron with drying group. That's why it's a more acidic nature. Suppose another one, C double bond O and O, lone pair, minus lone pair, it is lone pair. G is raised to, it is a Z. So group. So it contains, it is a electron donating group. It is a donating group. It destabilizes the carboxylate ion. Ultimately, acidic strength decreases. Very, very important, my dear students. You have to comparison here. This one is a methyl. Methyl is a electron donating group. So see F3. F is electron with drying group. That's why. So it has a high acidic nature. This is a very, very important, my dear students. Based on this, you have to see here. Suppose, I'll give one example, my dear students. So it is a HCOOH, formic acid. Next one, CH3COOH. So next one, it is a C2H5. It is a COOH. All are acids. See, all of you, is very, very important. It is formic acid, it is acetic acid, it is a ethanoic acid. You have to see here. So it is strong acid than this one, because of formic acid is strong than ethanoic acid, because of this is called as a electron donating groups. If a carboxylic acid contains electron donating group, acidic strength decreases. H, there is no donating, there is no withdrawing. So these are a plus I effect groups. Plus I effect, that is a positive inductive effect groups. If an acid contains plus I effect groups, acidic strength decreases. Suppose next one, acetic acid and ethanoic acid. Both are it is a electron donating group, it is also electron donating group. But in this case, as the number of carbon atoms increase, here one carbon, here two carbons. As the number of carbon atoms increase, acidic strength decreases. That's why this one. So formic acid is the strong acid than acetic acid. What is the reason? Here plus I effect group is there. So it is a CH3CH5. Both are plus I effect groups, but it is strong acid than this one, because of as the number of carbon atoms increases, acidic strength decreases. That's why this is strong acid. So it is a this one. Next one. Suppose see here, COOH. It is a COOH. It is oxalic acid. It is a COOH. See here. It is a CH2. It is a COOH. My dear students. Next one. CH2. It is a COOH. It is a CH2. It is a COOH. Next one. CH2. It is a COOH. It is a CH2. It is a CH2. It is COOH. Which is strong acid here? It is an oxalic acid, is strong acid than this one. You have to comparison here. All the compounds are dicarboxylic acids, but here Okay, so it is a electron donating group. One, okay, here one carbon, here two carbons are there, here three carbons are there. That's why this is a more acidic nature than this one, than this, okay, this one. So it is a carboxylic acid strength. In presence of, it is a positive I effect groups. Suppose in case negative I effect groups are there, what happened here? See here. So it is a CH3COOH. Okay, see all of you. Next one, it is a CH2. It is a F. See, okay, it is very important, my dear students. And the COOH. COOH. Next one, it is a CH2. It is a Cl and the COOH. COOH. Next one, CH2 and Br. It is a COOH. It is a compound 1, it is compound 2, it is compound 3, it is compound 4. Among the compounds, which is strong acid, it is very important, my dear students. 1, 2, 3 and 4. Okay. Comparison between, okay, so this one, so it is a plus I effect group. So this one. So remaining, it is a, these all are, okay, fluorine, chlorine, bromine. These all are, it is a electron, it is a withdrawing groups. In that, which is more electronegative, this one, that is a 2 is greater than, next one, 3 is greater than, 4 is greater than, okay, and 4 is greater than, it is a 1. This is the acidic strength order. It is very important, my dear students. Next one, you have to see there, suppose, okay, see here, CH3, okay, it is a CH, it is a COOH, okay, see here, it is a F, okay, next one, it is the first compound and second compound, see here, it is a CH3, sorry, it is a F and CH2, it is a COOH. And third compound, it is a CH3, CH2, it is a COOH. Comparison between these two, okay, so same number of carbons, 1, 2, 3, 1, 2, 3, same number of carbons, but here it is alpha position, it is beta position. Fluorine at alpha position and fluorine at beta position, which is near to the carboxylic acid, alpha 1. This is a strong acid. 1 is greater than, 2 is greater than, okay, it is a 3. Because of there is no, this is a positive I effect groups. Very, very important, my dear students. Okay, so this is a very, very, very important concept. I hope all the students are understood this one. The next one. Okay, next one, acidic. Okay, so reaction due to or cleavage of OH bond. Cleavage of, first property, cleavage of, it is a OH bond. Very important, my dear students. If you take this a CH3, C double bond O and OH plus is reacting with sodium metal, gives rise to, what happened here? Cleavage in between this one, that is a H place is occupied by Na, that is a CH3, C double bond O and ONA. It is a sodium acetate, it is a salt, and half H2 gas is liberated. Next one, half H2 gas. Next one, CH3, C double bond O and O, it is a H plus it is a NaOH, sodium hydroxide. Okay, same thing here, bond breaking. Okay, that is a, here also same, here bond breaking. H place is occupied by Na, that is a CH3COONA plus this H and OH. Water is formed. Next one, it is very important, my dear students. Next one, CH3, C double bond O and O, it is H plus it is a Na2CO3, sodium carbonate. Same thing here, bond breaking. This place is occupied by, it is a CH3COONA, sodium salt, and the CO2 gas is separated and the H2O is formed. These all are, it is a cleavage of, it is a OH bond.